Hello everyone, welcome to ROCFT Institute. Today we will be discussing irrational numbers. This is the part 2 video for class 9 CBSE maths. If you didn't knew that this video was going to be made, this is this part 2 video of class 9 mathematics chapter 1, which was number system, and I had already made the part 1 video. If you haven't watched that video, you should go and watch that video first. The link will be in the card section up right over here or here, I don't know, but it will be there. You can go and click in the card section and watch that previous video and then come back here and watch the part 2 video. Today's topic will be irrational numbers. If you don't want to go with the part 1, you can continue with the part 2. There is no problem. Just if you didn't know about the rational numbers, then you have to watch the part 1 video. Okay, so today's topic is irrational numbers. Irrational numbers are really unique in the whole number system, in the whole number line. You know, we just go back to the rational numbers. If you remember, what are rational numbers? I said rational numbers are those numbers which are in the form p by q and q is not equals to 0, where q and p both are integers. Let me explain that once again. So rational numbers what were these numbers? These numbers are in the form p by q, where p and q both belong to integers. P and q both belong to integers. That means they are either 1, 2, 3, 4 or -1, -2. Okay, and this q is not equals to 0. These are the three conditions. They are in the form p by q, condition 1, p and q both are integers, condition 2, and q is not equals to 0. This is condition 3. But with irrational numbers, it's a little bit different. Irrational numbers are numbers that cannot be represented in the form p by q, where p and q are integers and q is not equals to 0. Just the opposite of rational numbers. Irrational numbers is just the opposite of rational numbers. Why do I say so? Like, let me give you an example of rational number. 1 by 2. 1 by 2 is, we know, 0.5, but this 1 by 2 or this 0.5, these both are rational numbers. Means they are both the same number. So 1 by 2 is a rational number. But root over 2, the value of root over 2 is 1.414. Now this number is not a rational number. This is an irrational number. Okay, so this irrational number cannot be represented in the form p by q. So you cannot write this number in fractional form. That's the difference between rational and irrational numbers. So the definition of irrational numbers is very simple. The definition of irrational numbers is that these numbers cannot be represented in the form p by q, where p and q belong to integers and q is not equal to 0. That means this set of numbers, irrational numbers, they cannot be represented in the number line firstly, where p and q means they cannot be represented, sorry, did I say number line? They cannot be represented in the form p by q, where p and q belong to integer set and q is not equal to 0. This was the definition of rational numbers. Now, so rational numbers, the opposite of rational numbers is irrational number, and they cannot be represented in the form p by q, which is the fractional form. Now there is a quite little bit of history behind these irrational numbers. Around 400 BC, the Pythagoreans, means the followers of the great mathematician and philosopher Pythagoras, among them there were few mathematicians who discovered this irrational number theory. And there are many myths, and there are many funny myths too. We go online and you search for it, you will get a lot of them. But whatever they are, Hipparchus in all of the myths have a really tragic end. and you should go and read that story. Now let's focus on irrational numbers. Now, examples of irrational numbers. Examples. Can you name any example of irrational numbers? I said one, that's root 2. Root 2 cannot be represented in the form p by q. There is no fraction which can represent root 2. Can you name more examples of it? Can you name more examples of irrational numbers? There are many. Can you name them? If you know anyone, just go to the comment section and comment down below. I'll definitely appreciate all of that. Now, examples of irrational numbers are root 3. Root 3 is also the example of irrational number. The value of root 3 is 1.732. Why am I writing the values of root 3, root 2? These values are important. But not right now, but they will be important in your singing classes. So it's a good practice to know about these values right now. So root 3 is there, root 2, I told the value of root 2, 1.414. Then there is root 15. There is pi. The value of pi, as far as I remember, is 3.14, and more goes on. Now there is also this special number which is 0.1011001100111000, and this repetition goes on. Just pay attention to this number specifically right now. What do you see? You see that after this decimal point, 1 is there only one time, then there is 0, then 1 is repeated 2 times and 0 again repeated 2 times. You see 1 repeated 3 times and 0 3 times. So you see this repetition, not 2, 1. So over here you are seeing a specific repetition of 1, 2, 3, 4, 5, 6, 7, and it goes on. This is a very special irrational number. There are many uses of this number, and this number also cannot be represented in the form p by q. This cannot be represented. Now, there are many types of problems in this chapter based on irrational numbers, but very few are given in the NCERT book. If you want to solve lots of problem on this irrational number section, then I would rather suggest you go to R.D. Sharma. There you will get lots of problems and you will also enjoy solving those problems. We are also going to do some of those, and let's find out how those problems tend to end up. Now the most common and basic type of problem that you will see in irrational number chapter or irrational section is this problem, that you will be told to represent root 2 in the number line. Now how to do that? Simple. Just draw the number line. Okay, draw the number line. I'm drawing a freehand. Now keep in mind, I'm doing a freehand diagram. You don't have to do this freehand diagram. You can take your scale, properly measure everything and then draw. Okay. Now this is suppose 0, minus 1, minus 2, minus 3, minus 4, minus 5. 1, 2, 3, 4, 5, and it goes on. Now let's recall back. Okay. Now root 2. Where do you get root 2? Take a triangle. Okay. Take a triangle. Don't need to name it. Okay, I'm naming it A, B, and C. Okay. Now AB is suppose 1 centimeter and AC is suppose 1 centimeter. Both these sides are equal. Now applying Pythagoras theorem, which is h square equals to p square plus b square. Okay. So I have to find the hypotenuse, which is BC. BC will be p square is 1, p square, that is 1 square is 1 plus 1. So 1 square plus 1 square is 1 plus 1, and that is root over that, and we get root over 2. So the hypotenuse of BC is root over 2. Okay, but how did I get it? Pay attention over here. I got root over 2 by simply taking the perpendicular as 1 centimeter or 1 unit, whatever you say it, and the base as 1 centimeter or 1 unit. The same thing you have to do over here. Draw the number line and then take 1 centimeter. Take from 1 to 2, no problem. From 1 to 2, 1 centimeter, and draw a perpendicular line. A perpendicular line of 1 centimeter. Measure it very clearly, okay? And then draw that. After drawing, draw this. After drawing this 1 centimeter and also taking 1 centimeter, this base is 1 centimeter, the perpendicular will be also 1 centimeter. Now connect these 2 points from the base to the tip of the perpendicular. This is root 2, isn't it, according to this Pythagoras theorem? Now take your compass, measure this one, okay? Take your compass and measure this part. After measuring it, draw an arc. The arc will look something like this. Let me draw. If you draw an arc like this, see over here, you will take this one and you will draw an arc like this. So the arc will look somewhat like this, okay? Not like this, I guess. Okay. Okay, so now this kind of problem is going to be one of the most common ones. So pay attention, and how we will do it, I'm going to explain it over here. Many students will find problem solving this sum, and definitely this is one of those sums that is going to come in the exams. And not root 2, root 2 is very easy. There will be root 5, root 7, something like that. So pay attention, okay? So my question is, represent root 2 in the number line. How will I do that? Now let's recall back something. Do you remember the Pythagoras theorem? What does it say? It says hypotenuse square is perpendicular square plus base square, okay? Now if I draw a triangle where the base is suppose 1 centimeter or 1 unit and the perpendicular is also 1 centimeter or 1 unit, automatically the hypotenuse will be BC equals to root over 1 plus 1, which will be root over 2. So BC will be root 2, or hypotenuse is root 2. The same thing I have to do over here. Take 1 centimeter from 0. From 0 to 1 is 1 centimeter. Take that 1 centimeter and draw a perpendicular. Carefully draw a perpendicular over 1. That is also 1 centimeter. So this should be 1 and 1. Both should be 1. Both should be equal. That is very important. And this should be perpendicular to the number line. Now connect both of these. Connect the base and the tip of the perpendicular. And take your compass, measure this one and draw an arc. When you do that, you will get somewhat over here, okay? When you cut an arc. Now from 0 to this point, this is your root 2. So from 0 to this point, this is your root 2, which is 1.414. So this point is the one, okay? Root 2 was a little easy, okay? Let's go to root 3. If I am asked to represent root 3 in the number line, how will I do that? So root 3, how will I get root 3? Very simple. Root 2. Take root 2 as base. Take root 2 as base, and this is 1 centimeter. Or you can take this one also as root 2 and this is as 1 centimeter. Like this one. You can take also this one also 1 centimeter. This is root 2. What will I get over here? Root 2 whole square, which will give me ultimately 2 plus 1 root 3, isn't it? You can see, solve it by your own and then match the values if it's matching over here. Now what do you see over here? You take the perpendicular or base, either one of them, as root 2 and leave the one as 1 centimeter, and the hypotenuse comes out to be root 3. So you have to do the same thing over here in the number line. You see, pay attention over here. This line is root 2, isn't it? We found out this line, this hypotenuse is root 2. Now what you need to do is just draw a perpendicular line of 1 centimeter from here to here, 1 centimeter, and then connect this one to this one. Connect the tip of that perpendicular to the base. Now what you will find is this point, this measurement will be root 3. This measurement will be root 3. Now the same thing, take your compass, measure it and draw an arc, which will almost be over here. When you draw an arc, you have to measure this one. Pay attention. When you draw an arc, you have to measure this point, from here to here. Take your compass, measure this one, put your compass over here, and then draw an arc or cut an arc. When you do that, you get the point. This is root 3. So this is root 3, which is 1.732. I know this looks quite messy and it might be difficult for you to understand, but I guess you got the idea. So here, how you do it. If you have any kind of problem, just draw a triangle, right angle triangle, remember, keep that in mind, and try to put here and there, adjust the values and pay attention to this hypotenuse. This is the main thing over here. Over here you get all of the values, root 3, root 4, root 5, root 6, root 7, everything you get over here. Okay, so pay attention to this hypotenuse. Do not bring the values in the perpendicular or base. Bring the values in the hypotenuse. That will be a lot easier, and that's the way to do it. So this was the main problem. Okay, many students face a lot of problem in this one. So I won't be doing exercise 1.2 there because that's quite small and easy for you all. You know how to do it. You know how I told you, I explained everything, how to bring the root values in the number line, how to represent all of those root values in the number line. That is quite easy. So do exercise 1.2 on your own, and if you want, you can submit the answers in the comment section, or I will be providing you a Google Drive link where you can go do those things and submit all of those on my social media accounts. You can submit that on Twitter, on Instagram, and tag me over there. Okay, so now our topic of discussion is real numbers and their decimal expansion. Okay, so you need to understand over here, the main thing that we will be doing over here will be finding out the values of some of the fractions. Suppose 1 by 3 or 10 by 3. Okay, 1 by 3. So our main attempt in this section will be to find out the values of fractions like 10 by 3 or 21 by 7, which is pi, or many other numbers. Okay, so we will try to find out the values of these numbers till as far as possible, and we will also be emphasizing on the term real numbers. Okay, so the term real number, what does it mean, and what is it in the number line? I have told you, I've given a little bit of introduction about the real numbers in part 1. You can go and watch that video again. I'm saying it again because I don't want you to miss all that. Now, but still, I will be explaining what is real number again, so pay attention. And that is, the question is very simple. What is real number? In the number line, 0, 1, 2, 3, and it goes on, -1, -2, and -3. It goes on too. Pay attention. What do you see over here is, you see all of these numbers. These are the positive values, these are the negative values, and this is 0, which is neither positive nor negative. That means you have the whole numbers, you have the negative numbers, you have all the set of integers. But again, you also have these irrational numbers in between somewhere, irrational numbers. Then you also have some of these rational numbers also, which are fractional numbers. So all of these numbers can also be said that they are rational numbers. But there's another set of numbers, the set of all numbers, the set of all numbers. Set of all numbers. All of the numbers, rational numbers, irrational numbers, natural numbers, integers, whole numbers, the set of all of these numbers are called real numbers. What are real numbers? There are some numbers which cannot be explained like this. Suppose 10.333, and it goes on. Will it stop? It will not stop. Now, how will I explain it? Pay attention. 10 by 3, solve 10 by 3. What will you get? Do the division method and solve it. Okay, so this was not root 10. Sorry if you just... 10 by 3. Solve 10 by 3. 3 3 is a 9. You will get again 10.3, and this will go on. So I can write 3.3 bar. That means what? This 3 over which the bar is there, this 3 continues, this 3 goes on till where? Till infinity. It doesn't stop. Okay, they are not finite terms of these. You can just go literally to infinity. You cannot, it will not stop. But one thing to pay attention over here is this 3.3 bar, this number, where will you put this number? Obviously this is a rational number, 10 by 3, p by q, where q is not equal to 0 and p and q both belong to integer number set. This 3.33 which goes on till really infinite, almost we can say infinite, but whatever. So this 3.3 bar, this number, this specific number, can also be said that this number belongs to the set of real numbers. Very simple. So this is real number. The real number is basically the set of all numbers. So 1 is also a real number, 2 is also a real number, 3 is also a real number, minus 1. So any number in the number line is a real number. Please clear this concept, because some students will come to me and say, Bhaiya, this is real number, that is not a real number, this is... I don't want to listen to that. Everything in the number line is a real number. Just exactly that. Full stop. It ends over there. You don't need to continue. Now, the common problems or sums that you will get in this section will be, the most common type of problem that you will find in this section is this one. You will be said 0.3333, it goes on. So this number 0.33333 which goes on, you will be said prove that this can be represented in the form p by q, or to prove that this number is a rational number, which means it can be represented in the form p by q. Now, how to do that? Very simple. We don't know what is this p by q, isn't it? We do not know from where this 0.33, from which fraction this 0.3333 came. So I can say x equals to 0.33 and goes on. Okay, I can say that. There is nothing wrong in saying that. So if I say 10 into x, if I multiply 10 with x, I will also have to multiply the 0.33 with x, because if I multiply anything on the left hand side, I have to multiply the same number in the right hand side. This is a rule. Okay, it's very clear. If you are finding any confusion, please comment down. I'll explain over there also. So 10 into 0.333 goes on. Okay, it's clear. So now I get 10x equals to 0.333 into 10 will be 3 point, because the decimal point will move to the right hand side, means to the right side, not right hand side. So 3.333, still it still goes on. Okay, so I multiplied this 0.33 with 10. Okay, now can I say that this number, this x, so now can I say that this 3.33, I got this 3 from 3.33 which goes on, I got this 3.33 by what? By adding x plus, by adding 3 to the x, na? So 3 plus x. Why am I saying I got this number by adding 3 plus x? Go to the first one. X value was 0.3333. Okay, so when I multiplied this with 10, I got 3.33. You can also see that 3.0000 when added with 0.3333, okay, let me write it clearly again. So 3.0000, it goes on, added to 0.333, it goes on. When I add this one, okay, when I add these numbers, what do I get? 3.33, it goes on. So I can say that because the value of x is 0.33, When 3 is added to x, I get 3.3333, and it continues. So I can say that 10x, because this one equals to this one, I can say 10x equals to 3 plus x. Why? Because 3.33 is I got from x plus 3. I'm not changing the number, I'm just basically solving it. I'm keeping it very simple, I'm not changing the number anywhere. So I can say, I can solve this one for x. So I will bring this x this side, which will give me 10x minus x equals to 3. I can write it like this, which means 9x equals to 3, or I can say x equals to 3 by 9, which will give me 1 by 3. So 1 by 3 is equals to 0.333. So I got the value of x. I said p by q was x, so I got p by q, which was 1 by 3. You can solve it and check if the answer is true. Now this is a very good thing. After solving the whole sum, even if you think you have some doubt, just solve it. 1 by 3. So 0.3, it's coming, 3. Yes. So you get it. So you get it. What we did here, we found out that this 1 by 3, it gives 0.33. Okay, we didn't knew this 1 by 3, but we found it out by applying the x method. There is also one more method by taking 100, but I will suggest not doing that one because this is a lot more easier, and this is the most fundamental method up till university. You just do with this method. Okay, still it's good if you know about how to do it with 100 or any other number or some other kind of tips, some other kind of method. It's not bad to know other methods, but try to do with this method, try to do with x method. Still, it's your choice. You want to do with other method, that's your choice. So this is the most common type of sum that's going to come. There is nothing more special about it. This whole real number system and all, it's very easy. Okay, so do not worry about this first chapter. This first chapter is very easy, quite easy. The sums are really easy sums. You won't get disturbed while doing the sums, but still you need to have some practice. Without practice, you will be slow, others will be much more faster than you, and in the examination paper they will do better. Therefore, practice as much as possible.